In here, it's also a central part of our business. It's outgoing orders we have here. And you can see this pair is actually a pair of M3s going out on Monday. They're actually sold here in Denmark. So it's the guys here, the local guys who have sold the M3s. But as you can see, we're coming around. So we are doing very well in Asia as well. Our biggest market right now is Europe. It had been US in former days. But then you got a president who changed it quite dramatically. So Peter is building it up now. You have to clean up because there was too much shit over there. It's when you don't find the right guys in form of distributors or whoever, it easily ends up in being really bad for you. So Peter's first job was to clean up. So now we are rebuilding US. I'm sure it's going to be our biggest market, but we do extremely well. Our biggest single country now is Germany. And that's very unusual because Germany is the second most difficult market in the world, next after US. You know, when you have worked for an American company for 20 years, you know that the US is not one country, it's 50 states, and each state has its own way of thinking, its own way of running their business. And for a lot of Europeans and Asian people, it's a pretty big shock. And a lot of companies have tried to set up distribution in US, and most of them have failed. And also competition in US is tough. You have a lot of main manufacturers have a big influence of the whole high-end business. And American market dominates the whole world. So this is the first of our demo rooms downstairs. And here we normally are showing the access products. We are showing power switches, LAN cables, and so on. So everything you see in front of you, we make in-house. We make the speakers, we make the electronics, we make everything, cables, everything. Yes, so that was the first of the demo rooms. So this is our lounge. And we have a lot of meetings in here as well. And right now you can see we have a little bit mix of speakers in here. I mean, you know the X-Series, Jay, the X1, X2, X3, and the XX. In here we have the second demo room down here. And it's a room where you're going to be listening to some stuff today. You're going to listen to the new generation of our power cords, our power distribution bars. And then it's our 880, our integrated 2x 200 watts Class A integrated. It's the chief designer for CH Precision and Stenheim speakers. He came on board for 1.5 years ago. And what he's in charge of now is he's working with our new phono stages. He's working with all measurements when it comes to noise radiation from the electronics, and also a part of the development group, the R&D. We are going to have a turntable one day, and you can see a prototype of his tone arm, and not going to look like this, but it's just an idea that we work pretty hard with it, and one day we will have a turntable and our own tone arm. But it's just to give you an idea. So it's a 3D printed titanium, and to reduce the weight, we have carbon around it. So one day we will have a turntable. We introduced the Axis electronics last year, the 1, 2, and 3. The idea was actually that it should have been built, assembled in China. But first of all, we would have no control for the result when it comes to performance. We also figured out that we could do it much better ourselves. The problem for a Chinese manufacturer who's assembling a whole amplifier is they maybe have to buy the output states amplifier from someone else, the DAC from somebody else, the streamer unit from someone else, and you can continue. So we gave up. I said, okay, we have to build it in-house. So it is handcrafted in Denmark. The foundation is still, we have, in any electronics we make, we have one of the best volume controls in the world, sitting anywhere. You have to remember that volume control is the heaviest filter you have of any. And if you ask me how many world-class preamps do you know, more or less none. Because most preamps out there are based on potentiometers or attenuators or relays. And when you have a potentiometer, you know that after a few years it starts to scratch. You hear it because the contacts are getting dirty. Attenuator, yeah, it takes a longer while before they're dirty as well, but they will get dirty. So you actually have a quality of a potentiometer here, an attenuator up here, but in the end result is out here, is down here. Relays, they're hopeless. Relays are really bad sounding. We have tried it out. So we have a resistor ladder where we by a computer adjust what is it called? The feedback loop. So we have no contacts. There's a few other guys who's doing that, but we have been working with this since we started the electronics for nearly 10 years ago. So we have a really, really high quality volume control sitting in any amplifier we make. A transformer by nature, it's why when we have transformers, in US we have better sound than in Europe because you have 60 Hertz. In Europe we have 50. And that means a transformer delivers instant current 60 times per second. But a resonance mode power supply delivers 400,000 times a second. That means you can use high quality small caps, and we have an extra power supply for the output stage here, and they will be fully charged the whole time. So they never is down or up, and you bigger capacitors you have in an amplifier, you slower it is, because to fill the capacitors up with 60 Hertz per second, you have an issue. They're never fully charged. Transformers have also other issues. Transformers have an issue called inductance, and we talked about inductance is bad for music, but transformers are increasing inductance by nature. It's coils. Another thing which transformers are bad at, or linear power supply, is high frequency noise goes straight through, there's nothing to protect it. And all the circuitry in an amplifier, in a CD player, whatever you have, will be under heavy influence from high frequency noise. They also use, in this case, resonant power supply in the Pascal itself, and we have extra over here. We use two qualities. In the intro level, we use Chinese resonant mode power supplies, but in the 880s, we use the best available, and then they're Japanese. They're used in the medical industry because they're extremely low on noise. It's a Korean company who's delivering it. I had the listening test to 5 different streamers from different companies. And this was by far the best one on its own. It was actually so good on its own with the external switch mode power supply. It outcompeted a very expensive, or 2 very expensive streamers out there on its own without the noise cancellation technology and so on we put into it. The DAC, yeah, you should talk to Michael about the DAC, but he used AI and said, what are the fucking studios using when they're doing a digital masters? And there was 2, and we listened to 2 of them, and we find the best sounding of them. So it is a ladder DAC, 1-bit streamer ladder DAC, but Michael have more to explain about that one. Our clocks are setting less than 1.5 millimeter from the DAC itself. It's where it should be. So when you have separate boxes with cables, it's fucked up. It's never going to work. We also have 1 layer of copper for grounding, so we have extremely high quality grounding anywhere where we need it around the processor. We also have 14 power supplies, so anywhere you really need instant current because, you know, most stacks are running pretty warm, and that means there's quite a lot of current running through them because of the signal transmission. So we really, it's a masterpiece actually you have in front of you. And I'm pretty proud in a blind test. when you can't see what you're listening to, I think I could change your mind setting quite dramatically for what a unit like this can do. And our i880 have deliver 200 watts class A in 8 ohms, 400 in 4 ohms, 750 watts in 2 ohms, stable down in 1 ohm, deliver peaks of 65 amperes peaks, and have a damping factor of only 12,000. No one else have that. The output to the P, the power amp, stereo amp, have 250 watts per channel and a damping factor of only 16,000. We are pretty proud to have something no one else has. So in here we have 4 guys. And then in the R&D team we have, of course, Ricardo. And then we have Mikkel and Michael and Bjarne in here. So we have 8 people producing electronics right now. Do we measure speakers? Yes, we do. But any speaker we make, we measure them to see they're assembled by human beings. And of course, on a driver, you can wrong polarity, change the plus and minus around or whatever, or component in the cross, or it doesn't work or whatever. We also use it for tonal balance. And that's it. The measurements are not what we really care about, except not making mistakes.
Okay. So no worries about the sound measurements are not taken into account when it
no, of course, if something is taken out, you have to do something about it. But the drivers you have less mechanical noise than more or less any other driver on the market. And when you're getting used to it, I saw your video from Next Level on the X1s. It plays like a big speaker if you don't know. And it plays like a big speaker because it has simply much, much less mechanical noise. And also electrical noise. So we measure the speakers to get rid of failures. We adjust the tonal balance, but we are listening transients. And that means that the treble, the time alignment, is what we worried about. That treble reaches that ear the same time as the mid-range at the lowest bass. If something is out of order there, we cannot have it because the transients are wrong. So any speaker we make, also in our new facilities, we have listening tests on it. And we have typically my son Emil and another guy here, and we have another guy in our new facilities. And they more or less spend the whole day listening to speakers. Because the mechanical breakups, or something sticking out, it could be a cable hitting the back of the drive or whatever. You can't measure it, so you have to listen to them. So that's what we do. So this is a prototype of the new C2. Unfortunately, we make a small mistake on them because the time alignment is not correct because they have to be tilted 5 degrees, 5.5 degrees exactly. So they're going to more or less look like this. Crossover everything, we have everything in order now, so, and they are performing absolutely gorgeously. So yeah, that's also a lot of new technology there. We have 2 guys in here only doing assembling drivers for the 2 top tiers of our speakers. The speakers like the X speakers, if we have to assemble the drivers in-house, you have to pay 3 times as much money for them. But we have a very good friend of ours we have known for nearly 30 years, Michael and I. His name is Leo. So he's assembling the drivers for the X and the L drivers and the C. Because he's one of the best in the world. He is better than Scanspeak and Sears and VIFA, whatever, Dyna Audio. High quality. So this is the X driver we have here. We have designed it in-house. Not only design it, but also develop it. So he just have to assemble it. So here we use a very strong ferrite magnet. And we have 2 pole pieces in iron. But you can also see, you can see them over here. we have two copper caps to reduce the inductance. So even here we have the same. We also, you can see it on the motor system, to reduce, and this is from the C series and also what we have been using until further in the C series, the old Z series. That's neodymium N52. That's a much, much stronger magnet. So the driver in the X have around 15-16% of the inductance of any other dynamic driver on the market. We will have the copper caps, as you saw, but we also have titanium voice coil former sitting here. I'm going to show why we don't use aluminum voice coil formers. And then we have the split toe, the carbon 3-layer. I'm going to show them. We make them in-house. When you go from the X to the new C series, it looks like this. Then we have changed the ferrite magnet to neodymium N52, which is around 6 to 8 times stronger than normal neodymium. We also have the two copper caps in here. This is, by the way, also copper. But also, here you can't see it, but between the top pole piece, we have a copper ring sitting here to make the iron distortion less. It's actually a very powerful engine. You can feel it. So when we came from Morado, this is simply like not us. We have no attention to make speakers again. I said, no, wait, Michael, all the concerns and worries we have had, we're not going to touch anything which have to do with the speaker. And of course, Michael comes and said, I have an idea. I was, okay, what is the idea, Michael? And he showed me on his computer that there was a car stereo speaker. It looked to me very similar to all the other ones, but no, I would wish it was me who invented it because they have close to none iron in their last. Okay. What does that mean, Michael? Yeah, iron makes distortion. So when you have a voice coil moving out, it's looking, depending if it's overhanged or underhanged, it's looking into less iron on its way out. But when we move inside, they look into more and more iron. And that means 400 hertz or 700 hertz out there is not the same as in here. That's iron distortion. So any other dynamic driver on the market, including these, but these have a minimum. So then I, as typical, asked Michael, can you do it better, Michael? Yes, I think I have an idea. So that brings us to this driver. Yeah. So we have the neodymium N52 sitting here, and we have the main side. So there's no iron here. So we have a copper ring in the middle. So we have it's a very powerful engine. They have a force of 1.12 Tesla. So it's an extremely powerful motor system, but it's very well ventilated. You have to have ventilation. Otherwise, you'll have compression. But there's one thing we didn't see coming is that when we have the copper ring in here, this driver have only around 10% of the inductance of any other driver on the market. And inductance matters. The lower inductance you have, you better transients you have. It's very, very simple. It's science, nothing else. So, and of course, one day we have a former guy, unfortunately left us for a few years ago. He was in his spare time doing jewelry in silver. Of course, we have to figure out how that works out. Oops. So here we have a silver ring, and inside in here we also have a silver ring. So we have around 1 pound of pure silver in here. Is silver better than copper? Because they have around 6 to 8% less inductance. So that means when you put silver in the motor system, you have only around 8% inductance of any other driver on the market. We have a silver room in here where we actually are warming the silver up to 1100 degrees Celsius and put it into a sand form. So each ring we have made in-house, machined it, and then we are sending the rings down to the Institute of Technology in Aarhus, where they're bombarding in a vapor particle accelerator for 92 hours, a layer of titanium nitrate, titanium, tungsten, zirconium, and pure silver. So these two pieces, the cost price for us is a little less than $3,000 netto. Okay, Jay, let's see how strong you are. We have a neodymium N52 over here. You take them out of the rack first.
Magnet?
Yeah, you can take them off. And then up! Be careful. We'll try to split them.
Oh, split it.
Yeah.
You can't.
Come on. These overarms should be able to split.
Okay. Yeah. You try it.
That's the magnets when we use neodymium N52. Oh, come on.